In this lesson, we're going to learn how to add together two rational expressions that do not have common denominators. As you can see in the example I give here, one of the denominators is 2x, the other is 2x minus 8. So in order to add together two rationals like this, we have to first find a common denominator. First thing I like to do is simplify anything I can in the denominator so I can see what factors they may already share. In this case, I notice that in the second denominator I can factor out a 2. So I would do any factoring that I could possibly do to make this simpler. Now once I've simplified all the denominators, I'm going to go out to the side somewhere. Right here will be alright. And I'm going to try to find my least common denominator. And the way I do that, pretty simple. I list all the factors in the first fraction. In this case, the 2 and the x. And then I look at the second fraction and I say, okay, what is not used in the first fraction that is used in the second? Well, in this case, it's x minus 4. So that's a factor that we need to add to our least common denominator. X minus 4. And if there were a third fraction, I would list anything, any factor that had not been used in the first two. So in our case, our least common denominator now is 2x times x minus 4. So I'm going to go down here and I'm going to write that. In fact, I like to write it all over one denominator now that I know what it is. My final answer will contain this. I'll actually work it out a little bit more. But now I'm ready to work on my numerator. So I'm going to put x plus 4 right here. That was my original numerator for my first fraction. And I'm going to multiply that by anything that's in my least common denominator that wasn't in the original denominator. In this case, x minus 4. It was not part of the original denominator of 2x. So it's an additional factor. We do this because in order to get from 2x to 2x times x minus 4, we had to multiply the denominator by x minus 4. So now we have to multiply the numerator by the same thing. Now I'm going to do the same thing with the second part of the second fraction. I need to extend my line here. And I'm going to write the 3x minus 12 down. And I'm going to multiply 3x minus 12 by any factor that wasn't in the original denominator. 2 was, and x minus 4 was this time, but this time x itself was not. So we have to use this x right here and multiply it by the numerator. So I've made some progress here. And now I need to start combining terms. I noticed that x plus 4 times x minus 4, that's simply factors of the perfect square x squared minus 16. If you didn't recognize that or didn't know that, you could always just multiply those out by using distributive property. X times x times negative 4, and then 4x and 4 times negative 4. Then the middle 4x's would cancel. Then the second term here, I'm going to distribute my x. So 3x times x is 3x squared. And x times negative 12 is negative 12x. Here I ran out of room over there. And all of that is over the common denominator, which I'm going to go ahead now and also distribute. 2x times x is 2x squared minus 8x. Not quite finished because on top I still have a couple of x squareds that I need to combine, and I need to put it in the right order of descending exponents. So I have x squared plus 3x is 4x squared. And then I have minus 12x and minus 16. And all of that is over our common denominator of 2x squared minus 8x. And we will have added together those two fractions, those two rational expressions that have different denominators.